This is problem 14 on the worksheet Manipulating Vectors with Trigonometry. We have a force table. It's a common piece of equipment in a first-year physics lab. And you have three forces. Here, two are known. We want to know the third force that's going to balance these two forces. Should be somewhere down here, pulling this way to counteract these two forces. So if there's going to be no net force, the force in any direction must be zero. So let's define the x-axis horizontal, the y-axis vertical. The horizontal and vertical components of the 20 Newton force, positive x and positive y. This angle is 70 degrees. So cosine 70 times 20 newtons will give you the x component, which is 6.8. 20 newtons times sine 70 will give you the y component, which is 18.8. For the 14 Newton force, the angle from the positive x-axis is 150, so this angle is 30. So 14 newtons cosine 30 will give you the x component, and it's negative. And 14 newtons sine 30 is right here, the opposite, and that's positive y, 7 newtons. With the components, it's easy. Let's put the components on the diagram. There's the 14, 7 and 12.1. Get rid of the 14. The 20 is 18.8 up, 6.8 over. Get rid of the 20. The total vertical force from the two known forces is, they're in the same direction, we add them, is 25.8. In order for the net force to be zero in the y direction, the third force must have a y component of 25.8 newtons downward. So let's put that in the diagram. There it is. Now let's do the x direction. We have 12.1 to the left, 6.8 to the right. That's a net of 5.3 to the left. In order for the net force to be zero in the x direction, the third force must supply 5.3 newtons to the right. Let's put that on the diagram. There it is. Now we can see 25.8 newtons up, 25.8 newtons down, 12.1 newtons to the right, 12.1 newtons to the left. Total force is zero. So now we can calculate the magnitude and direction of this third force. There's the original two forces and the third force that we calculated. We can use the Pythagorean theorem. The magnitude is 26.3 newtons. The angle from the positive x-axis, this angle down here, it's going to be 80-ish because the y component is so big. The opposite side is 25.8. The adjacent side is 5.3. Arctangent is 78 degrees. So the third force that balances the first two has a magnitude of 26.3 newtons, and it's 78 degrees below the positive x-axis, and that is 282 degrees on the force wheel. So let's add this vector to the diagram. There it is, and we can get rid of the components. And if we look at this, we can imagine that if there's a tug of war, it's going to be a tie. Congratulations if you're getting good at this. It's not easy.